Hello, so today we are going to do leak code number 200, which is number of islands. And this is asking us to count the number of islands in a matrix. And so an island is a group of ones that are connected vertically or horizontally. So in this example, we can count the islands by going through each cell, saying, hey, this is not an island, not an island, not an island. And then we mark one, and then we try to find if there are other ones around, right? So there's a one here, there's a one here, and then we check, and there are no other ones around. So we keep going, go, 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 go. And there's one more island, so that's the second island. And then we have this one, and then we keep going, and then we have one more. So in total, we have 5 islands. Now the tricky part is to figure out which islands we have, like if this is part of a different island. So the way to mark each island as it's visited, you can either keep like some kind of visited matrix, but the easier thing to do is actually just to drown each island. So what I mean by that is instead of having like, a 1 here, every time you visit a 1, you just drown it. So like, let's say you get to here, you just turn it to a 0, and then you get to here, you turn it to a 0, and that is just a one group. And each time we just turn these into zeros, so they don't get recounted when we go through. Okay, so the time complexity for this island ends up being mxn, right? And the space complexity is just O of 1, since we are just storing the number of islands. And it's m as in like one side of the array, or the matrix, times the other side of the matrix. And at worst, if all of them are 1s, we have to like traverse the entire matrix twice, because every time you hit a 1, so if you hit a 1, then you have to like traverse the adjacent cells to see if they are also 1s. So at worst, I would say it's like 2x mxn, which just comes out to big O of mxn. Okay, so let's take a look at the code. So first we initialize a variable to store the number of islands that we have, and then we go through each cell of the matrix, and then we run the depth first search function whenever we encounter a 1. Now this function just drowns out the islands. So basically, if you reach a 1 here, then it proceeds to drown out all the adjacent islands. So it would drown out everything, and this entire matrix would become a 0. And the way it works is, well, we have a base case to make sure that the island is indeed in the matrix. So we can't have like a index of -1 or index of over the length of the grid. And we also need to make sure that it is equal to 1 in the cell, or otherwise it will not drown out the island. And so whenever it hits a 1, then we use this to drown out the island. And then we proceed to check the adjacent ones. So this would be to the left, this would be to the right, this would be above, and this would be below. And so we proceed to drown out all the adjacent islands, so that this, when you get back to here, you only add 1 island, and you make sure that you don't accidentally add the same island again, right? Because if you're missing a 1, so if you drown out everything except for, like, let's say this one here, then your function will count this as 2 islands, and that wouldn't be the right answer. So to run this, so this is the time complexity of O of mxn, and the memory usage is pretty good too. So this beats 99%, and yeah, pretty much 98% of the other solutions. So a problem that is pretty similar to number of islands is this max area of an island problem. So you want to find the biggest area in the pool, right, or in the sea, And so you can get to here, that's a island with the area of 1. You get to here, that's an island with an area of 4. And so basically you just count all of them while also drowning them too. So you make sure you, like when you get to here, right, you can count to the bottom, to the right, to the right, and then the top and bottom, and then this counts as 6, an area of 6, and this would be the max area of the current matrix. And so this follows the same recursive logic as the number of islands problem. Since you're basically just you're traversing the matrix whenever you hit a 1. So it looks pretty similar, but this time you just have these integer values to represent how many, how much area is to the left and to the right, to the top and the bottom of the cell. So if you were to go here, you would have left of 2, right bottom of 0, top of 0, and right of 3. So 2 plus 1 plus 3 would equal 6. And sometimes you just have to just believe in the recursion and just know that it will pull through for you and give you the right answer.